let's jump into page 7. Okay, we're going to solve some inequalities. So an inequality looks like an equation, except instead of an equal sign, it has an inequality symbol, less than, greater than, less than or equal to, and so on. So we solve it just like any other equation, right? So here I need to collect all the x's to one side, so minus 4x minus 4x. So this is x minus 3 greater than 2. Add 3, x is greater than 5, right? So when you have an equation, you solve the equation and you get, x equals 5, or you get, x equals negative 1 over 4. And so your only solution is that 1.5, negative 1 over 4, right? But when you have an inequality, you don't just have one solution, you have an entire range of solutions, right? So in this case, it's x is greater than 5. So any number that's greater than 5 is a solution of this equation, including 5.1, 5.00001, right? Sometimes we forget about those. So the way we mark it over here is we go to 5. Because it's greater than, not greater than or equal to, we're going to do an open circle. And then we're just going to go with the arrow this way. Okay, so to remind you, right? When you have, yeah, remember? So when you have less than or greater than, you get an open circle. When you have less than or equal to or greater than or equal to, you get a closed circle. All right, so this is it over here, okay? Right, so let's take a look at this one. We're going to add 15 to both sides. So 4x is less than or equal to 36. And then divide by 4, x is less than or equal to 9. So I go over to 9, but this time I'm going to put a closed circle on 9, right? Because it's less than or equal to, and I'm going to go over this way. Okay? Make sure that's visible. All right? Yeah. It doesn't matter. As long as you put the arrow, it's understood that it's going to keep going forever and ever and ever. So the solutions that satisfy, the numbers that satisfy this inequality, let's say, 9 works, 8 works, 8.99 works, negative a billion works, right? Okay. Now, we just divided by 4 here, right? Multiplying or dividing by a positive number has no effect. It is no change. However, multiplying or dividing by a negative number reverses the direction of an inequality. That means you have to multiply, you have to change greater than to less than and so on. So in here, if I divide by negative 4, divide by negative 4, I have x here, 6 here, but the inequality will switch direction. So I will get less than or equal to 6. Oops, 6, not 7. Okay? Yeah. Oh, that's what you mean? That's fine. Okay. Okay. So here we go. To solve this, I'm going to multiply both sides by 5. Okay? Yep. Doesn't matter. If it switches, if you're multiplying or dividing by a negative number. Let's do a couple of examples and you'll see. So take a look at this one. I'm multiplying both sides by 5, right? So here I get negative 15x. Ignore the inequality for now. Here, the 5's cancel, so I get negative 4x plus 22. Now, raise your hand if you say the inequality will switch. Raise your hand if you say the inequality will not switch. Okay, right now, it will not switch because what did we multiply by? A positive 5, so it stays the same. Oh, yeah, no, right at this step. So the thing is eventually, okay. So now add 4x, add 4x. So I get negative 11x less than or equal to 22. Now divide by negative 11, divide by negative 11. Now the sign will switch. X is greater than or equal to negative 2. Okay, so negative 2 is right here. Now, you can draw your arrow like here, but if you want to do it like a little bit above, you can do that as well. All right, so it's more visible. Okay, that's section 5, right? Basically, there's nothing new there. You learned that in Algebra 1. Okay, I know that because I've covered Algebra 1 lessons where I've taught that. Okay, so now, compound and absolute value inequalities. You've also actually done compound inequalities in Algebra 1. So here we have one inequality. This is a simple inequality, right? And the answer will just be x is less than or greater than a number. A compound inequality basically has two inequalities, and they're grouped together by either the word and or. So take a look at this one. I have x is greater than or equal to negative 4 and x is less than 3. So let's graph this one. This one, x is greater than or equal to negative 4. I go to negative 4 and it's basically greater than or equal to here. And x is less than 3. So let's go to 3. 1, 2, 3. Open circle for this, right? But we're going to go in the opposite direction. Do you see how there is a region of overlap? That's your solution, okay? So in the real world, we would actually draw that, even like this. So if this is 0, right, this is 3, and this is negative 4, I would do a closed circle here, an open circle here, and just connect that point, the 2 points, okay? So the solutions here are, okay, is 0 part of the solution? Yeah. What about negative 3? Yeah. What about positive 3? No. What about positive 2.99999? Yes, right? Okay, good. So, and inequalities are usually not written like this, but more frequently, they're written like this as one inequality. So the graph of an and inequality is the intersection, we call it, okay? Not the area that overlaps. That's not a mathematical word, but intersection, all right? Okay, so let's solve this one now. Again, we have to get x alone. So we have to get everything away from the x. First, I'm going to subtract 8, negative 20, 4x. What is this? 24. Everything, yeah, to all 3 sides. So now divide by 4, divide by 4, divide by 4. Negative 6, less than or equal to x, less than or equal to, oh no, not negative 6, negative 5. So we're going from negative 5 to 6. So, this is an and inequality. Yeah. This is more acceptable. This is, yeah. So do it this. Don't separate this. Keep it like this. Okay, so we're going to go from, okay, so we have a closed circle on negative 5 and an open circle on 6. And if you want to see this more like visually, right, if you start reading from the x, so here this is saying x is greater than or equal to negative 5, greater than or equal to negative 5, right? But it's also saying if you go from here, x is less than or equal to 6, less than or equal to 6. So it's going to look like this. This is an and inequality. The area that we have covered is the area where both of the inequalities overlap, but we call it the intersection of the two. This is an AND inequality. When we write an AND inequality, make sure the smaller number is here, the bigger number is here, and the inequalities are always pointing the same way. This is how we write it, okay? We don't write it like this, right? That's like out of order, okay? All right. Yeah. Yeah, in honors, yes. Okay. Okay. Huh? It won't be the opposite because you go from smaller number to bigger number. It will never be the opposite. It'll always be the smaller number, then less than or equal to, then the bigger number. Okay? All right, so let's take a look at this one. So we're going to add 2 everywhere. Remember, equal opportunity. Don't leave anybody out, yeah? So negative 12, 3x, negative 3. We're going to divide by 3. Divide by 3. Divide by 3. Does the inequality switch or no? No. Negative 4x, negative 1. Okay? Don't go like, switch happy, right? Like just because there's a negative somewhere doesn't mean you have to switch. Okay, so we're going to go from negative 4, which is an open circle, to negative 1, which gets a closed circle, and it's the intersection, so it's this area here. All right. This one?
Wait, why is it a negative? Wait, no.
So this one we're going to add 7. So we're going to get 15 less than 3y less than 30. Then divide by 3, which means we get 5 is less than y is less than 10. No. 6. No, 10. Sorry, I wrote 5 and then I divided by 5. Okay, so we're going to go from 5 to 10, and it's going to be the intersection in between. All right? So far, like Algebra 1, yeah? All right. So let's make sure the phones are off when we put them, yeah? Okay, so the OR inequality is the union of the solution sets. And this is kind of like a counterintuitive word. Union means either or. So take a look at this one. We have x is greater than or equal to 5. So I take this and I'm going to graph it here. 5 closed circle, greater than or equal to goes this way. Or x is less than or equal to negative 3. Negative 3. This way. There is no overlap here, correct? That's why it's an OR inequality. They face in different directions. And so when we say union, it doesn't mean joined. It's kind of counterintuitive. Union means that or the other. Okay? That or the other. So, some examples, right? If, let's say, there is like a dance, and we're like, okay, if you're under 17 and above 15, you can go, right? Above 15, under 17. So do you see that's like the region in between, yeah? Or let's say we're like, okay, we're going to have like, bonding day. Either if you're above 16 or below 15. Do you see the difference there? So come if you're above 16, you're going to bond with your people. Come if you're below 15, you're going to bond with your people. Do you see the disconnected situation there? Yeah? Okay. Okay, so OR inequalities are written like this, and we don't combine them into one. We leave them separately. We solve them as, little mini inequalities. So here I'm going to divide by 5. Dividing by 5 is the same as multiplying by 1 over 5. So here I get j greater than or equal to 3 over 2. Or here I'm going to divide by negative 3. Dividing by negative 3 is the same as multiplying by 1 over negative 3. So here I'm going to get j is what? less than or equal to, we switch, negative 7/5. Okay, so j is greater than or equal to 3/2, which is 1/2. Or less than or equal to negative 7/5, which is how much? 1 and a little bit, right? Okay. Any questions? All right. So let's do the next one. Yeah.
I'm confused how to do, like, how the negative is
So if you have like 3, and if you want to divide it by 5, that's the same as 3 times 1/5. So you can either divide by 5 or you can multiply by 1/5.
Oh, so
Divide by 5 means multiply by 1/5. Yeah? Okay. So here I'm going to subtract 1/5. So I'm going to get k is less than negative 3 minus 1/5. How much is that? Negative 16/5. Good. And then here, what am I going to do? Multiply by what? 3/2. So I get, or k is greater than or equal to, how much? 21. Oh, and I went and changed this over the summer, but I still didn't make it big enough. Okay, it's fine. So negative 16/5. How much is negative 16/5? It's basically negative 3 1/5, right? So negative 3, so this is 2, negative 3 1/5 is here. We're going to, oh, it's open circle. We're going to go less than. Greater than or equal to 21, so we're here. We're going to go that way. Okay, it's up to you to make sure that your open circles look like open circles and your closed circles look like closed circles, right? If it doesn't look, clear, if it's not clear, you can't get full credit. Okay, so here, what am I going to multiply by? 3/2. So I get x is less than what? 9. Or, okay, so I add 1. So I get 3x is greater than negative 6. X is greater than negative 2, right? And so I'll just write this over. X is less than 9 or greater than negative 2. Okay. Now, let's graph this. X is less than 9. What region is that? All of this. X is greater than negative 2. What region is this? Now, this is an or, right? So all of these numbers or all of these numbers work. Are there any numbers that are left out? This is or, not and. Are there any numbers that are left out? No. So this is actually all real numbers. Okay? So we say all real numbers, and then you have to realize that it's all real numbers, and you have to make your arrow like this. Okay. And so usually on the test or the quiz, you'll have an answer space, for like C, right? You'll have an answer space. On the answer space, you're going to write all real numbers. Or you can actually write all real numbers. Is everybody familiar with that symbol for all real numbers? Okay, so this is how you draw it. This is how we draw an R, correct? Okay, it's not this. So you draw a bar, another bar. You start from the first one that you drew, the left one, and you just go this. Okay? Bar, bar, left one, curve. Okay? Don't get don't get artsy with this, right? Like it's specific, all right? Yeah. Yeah. Yes, X is within the set of all real numbers. Like this, yeah, it's the same. It's a more formal way of writing it. So this says, yeah, this says X is within the set of all real numbers, but you can just write all real numbers like this, okay? Isn't that fun? Right? Okay, so we'll stop here and then we'll continue next